And so that is what the equilibrium constant expression for that equation would look like. Just to remind ourselves, it's always products over reactants raised to the power of the coefficient, right? And what stuff shows up in the equilibrium constant expression? Gases and aqueous only. Remember that? We never, if there's a solid or a liquid in the equation, we do not write that in the KEQ. Okay, I'm going to give you that the KC for this equation is 6.9 times 10 to the 5. Is that a big number? That's a pretty big number, isn't it? 6.9 times 10 to the 5. What would that tell you about this reaction going to completion?
A lot more products.
Yeah, since that's a really big number, then doesn't that tell y'all that there's a whole lot more products than there are reactants? That this reaction goes way to the right. If I had a really small equilibrium constant, that would tell me that there's a whole lot of reactants hanging around. All right, I'm going to take that and I'm going to write a different equation that looks like this. 2NO2 gas, still equilibrium, makes 2NO plus O2. No?
6.9 10 to the 5th.
Yes, 6.9 times 10 to the 5. Yeah, it kind of ran off the screen.
Is this like a review for Monday?
No.
This is something completely new, right?
Yeah, we're about to do new. That little bit right there was Monday's review. The equation I just wrote, guys, how does that differ from the first equation?
You're making
It's the reverse reaction, isn't it? So what would the KEQ look like for this second equation? Yeah, isn't it going to be what I have up top, just flipped? Okay, so you can write that if you want to. You don't have to, but here, we'll write it just to show that the KEQ is what I initially had, but it's flipped, or we might even say the reciprocal, yes? What would the KC for that second equation be? Exactly. Wouldn't the KC be equal to 1 divided by 6.9 times 10 to the 5? Because isn't that the reciprocal? That's the flip of it, isn't it? What was that?
Did you give us the KC? Or did you figure it out?
I gave you that. So I would divide that out. 1 divided by 6.9 times 10 to the 5. Y'all will have it before I do. Say again.
1.45 times 10 to the negative 6.
1.45 times 10 to the minus 6. What are the units of that? There are no units for an equilibrium constant.
So, question,
Yes.
we just assume that the numerator is just 1?
Well, that's what it means to flip it, is to take 1 over.
But it's just
Yes.
not everyone be like 2.398 or...
No, it's going to be 1 over. It's just going to be the flip of it. Same equation. This time I'm going to change it like so. I'm going to say 4 NOs plus 2 O2s in equilibrium with 4 NO2s. How is the equilibrium constant expression for the equation I have in red going to be different from this one I have in black? Because the one that's in black matches the equation in black. Is it double? This is what changes, right? This is now 4. This is now 4. And this is now 2, isn't it? Isn't it what I originally had in black squared? It is. So if I know for that original equation in black, what did I say that the KC for that one was?
6.9 times 10 to the 5th.
If the KC for the original one is 6.9 times 10 to the 5,
Square.
then how do I get the KC for the one in red? Yes.
4.8 times 10 to the 11.
I would square that. And tell me again.
4.761 times 10 to the 11.
4.76 times 10 to the 11.
Be 12, no. 4.76 times 10 to the 12.
Oh, to the 12, I'm sorry.
Yeah, we covered-
Oh, no. Yeah. No, it's 10 to the 11th. 4.76 times 10 to the 11. You see how I knew that? Because if you double the coefficients, because where are the coefficients applied in the equilibrium constant expression? They are the exponents, aren't they? So if I double the coefficient, that means I have to take the KC and raise it to that power. If I tripled the coefficients, what would that do to the KC? You would cube it. What if I halved the coefficients? Exactly. The square root of this is what takes me back to the original problem, doesn't it? Okay, given those two equations, what would those two equations add up to be? We kind of did a little bit of that at the end of the kinetics chapter. Yes. Y'all recognize that those cancel out, and you see that A plus B yields D plus E. How would I come up with the equilibrium constant for those two added together? I don't add the equilibrium constants. I multiply them together. So in other words, to get the equilibrium constant for A plus B yields D plus E, I take the 4.39 times 10 to the minus 3 that I'm given for that first equation. I multiply it by 1.15 times 10 to the 4. And when those are multiplied together, that gives me what? 50.5. That gives me an equilibrium constant of 50.5. And I got that by multiplying those two together.